Good morning to all. My roll number is 2095 1A04H5. Section B. My topic is about CPU scheduling for power or energy management on multi-core processor using cache, miss and context switch data. Introduction. Advances in process production have led to not only an increasing in the number of cores on a single chip, but also contaminate increasing in power consumption and heat dissipation associated with this high performance system. For example, 2.8 GHz Intel Nordwood Platinum 4 chip consumes around 80 watts, while a Precoat Platinum 4 chip of the same speed consumes around 100 watts. This increased power consumption creates an associated increasing in heat dissipation, which leads to higher costs for conditioning, thermal packing, fans and electricity. Increased heat and temperature of the hardware such as CPU can also lead to decreased longevity and great incidence of failure of these components. Also, the in generation of designing of a multi-core chip is more difficult to message than a lower density single chip design due to thermal constraints. Finally, power saving and architecture in which the processor have the same instruction set and microarchitecture, but that operate at different frequencies, adopting dynamic frequency scaling DFC to reduce power consumption. Any reference to a multi-core processor or system used for this research shall imply such an architecture. Heterogeneous architectures may achieve a higher performance per watt than comparable homogeneous system due to the ability of each application or run on a core that best its architectural properties. Even through architectures with core operating at different frequencies may still be consumed homogeneous. Such as architecture may contain core specialized for certain tasks. For example, thread conducting CPU intensive work may execute upon high frequency cores, while thread conducting memory intensive works may be executed upon low frequency cores, which consumes significantly less power. Due to the slow speed of cache and memory access relative to the processor speed, processes whose performance is limited by available memory bandwidth may obtain limited benefit from increasing processor frequency. Thus, when executing a task containing both CPU intensive and memory intensive processors, it may be beneficial to move such memory intensive processor to low frequency cores, while allowing less memory intensive, more CPU intensive processors to execute upon higher frequency cores. Context switching less CPU intensive processor that would benefits less from executing upon higher frequency cores to lower frequency cores and allowing CPU intensive processor to execute upon higher frequency cores may minimize the performance loss while providing significant power saving. Doing so while utilizing processor priority has a scheduling also beneficial, since a processor which is context switched to often may not be find valid data in its new core caches after being migrated to a new CPU. This processor will have a tendency to generate many cache misses. this overhead associated with the performance of multi-core processor system. Thus it may be advantageous to implement a different strategy in this scenario. This researcher goals is a identity and quantity disadvantages, like some recent works using server load, which may includes a heavy load system a heavy load system Hence, in our survey, we can evaluate hardware components that are identical or similar, which may be the case in typical server. DAC 1.2 outline of a paper in the supplementary files of this paper, which available in Computer Society Digital experimental setup and methodology used to generate a multi-core architecture with cores operating at different frequencies, and discuss how this methodology was used to implement and test our CPU scheduling algorithms. A discussion of related work is include a section 2 of the supplementary process in the ready or wait queues, which chooses an IPC threshold of 1.7 based upon process performance data, indicating that these processes had IPC value generated than 1.7 during initial phase of execution when choose a fraction wait time, not spending any time waiting in the ready at output queues, and one which signifies queues 7 in caches. MISI is equals to caches reference is higher than threshold. The process is evaluated as true if the process reference generated. We choose a cache miss index threshold 0.0014 because scheduling strategy is the ratio between the number of caches misses and catch all executing process in our experimental group. Based upon the experimental data, a value of 0.0014 represents this threshold. Due to slow speed of cache and memory accesses relative to the process speed, processes whose performance is limited by the value memory bandwidth may obtain limited benefit from the increasing processor memory intensive process. It may be beneficial to move such memory intensive processor to the lower processor. The performance of a multi-core processor system. Decreasing heat production can be crucial in netbook computers. Our battery life is constraints, and cooling of hardware components is difficult, and server can cause a significant saving for the entire system. Voltage and F is the effective bus frequency. Dynamic voltage scaling DVS is decreasing the voltage used by the CPU depending upon circumstances in an and power consumption. DVS causes an increasing in circuits delay, thus creating homogeneous architecture with cores having the same instruction set but that operate at different frequencies. The class of architecture used in this research is such an while core belonging to different subsets operates at different frequencies. Hence, in our evaluation, we try to emulate the most common commercial causes large latencies while waiting for this course to power up. Again, we fixed frequency course. In these researches, we addresses servers platform utilizing the executing benchmark also in order to exclude all our variables. We want to access potential power saving and performance improving our hard devices. Hence, our survey we evaluate hardware components that are identical or similar, which may be causes in the typical server rack 1.2 outline of a paper in supplementary like to file 2. Session 5 of this main file, we summarize our work and process ideas to extend this research. Feedback driven property based CPU scheduling algorithm. In this session, we present an application driven feedback, mediated CPU scheduling, and the total number of catchy reference generated at runtime. It also utilizes priority CPU scheduling, CMPC, PCS 2.1 variable and constants used in algorithm more process to be scheduling and executed by multi-core or many core chip NUM chips. Number of CPU cores on multi-core or many core chips. CPU intensity measures of the CPU intensity of the process. PI average CPU utilization of all cores upon which PI is executing. The property of the CPU intensity. Priority index C, an index that takes into account the CPU intensity. Load average system load over the period time. Number of processes using or waiting for all CPU. Thank you.